Bismillahirrahmanirrahim. Binary operator. Consider a non-empty set G star is said to be a binary operator on the set G if for each two elements A, B in a set G, A star B is equal to C. The result must contain in the set G. Then the binary operator, the operator star is said to be a binary operator on the set G. For example, the set n of all integers, and we have to check that addition is a binary operator on the set n of all integers. That is, for each two elements of the set n, that is A and B are any two natural numbers. The set n of all the natural number containing all positive integer 1, 2, 3, 4, that is the set n, the set of all natural number. And when we add any two natural number, and when we add any two natural number, the result must be a natural number. Therefore, addition is a binary operator on the set n of the all positive integer all, or we can say that the addition is a binary operator on the set n of all natural number. Another example, that is to check the subtraction, the binary operator subtraction on the set n of all natural number. We check it by a counter example. That is, suppose that A is equal to 2 and B is equal to 3. These two numbers, we select these two numbers from the set of natural numbers, and we have to check that B minus A, in this case B minus A, B is equal to 3 and A is equal to 2. 3 minus 2 is equal to 1, which is contained in the set of natural number. But A minus B, which is equal to 2 minus 3, the result is minus 1, which do not contain in the set of natural number. It is this resulting quantity is not a positive integer. Therefore, the subtraction is not a binary operator on the set n of all positive integer or the set n of all natural numbers. Another example, that is Z7 consists of the elements 0, 1, 2, 3, 4, 5 and 6, and we have to check this set is a residue classes modulo 7 under addition and multiplication. That is to check that addition and multiplication is a binary operator on the above set under the condition of residue classes modulo 7. That is, to check the addition, that is substitute, we construct a table for the calculation for the checking of addition, that is 0, 1, 2, 3, 4, 5 and 6, and substitute these elements in this table, that is 0, 1, 2, 3, 4, 5 and 6. Now add this element with each of these elements. 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 0 plus 2 is equal to 2, 0 plus 3 is equal to 3, 0 plus 4 is equal to 4, 0 plus 5 is equal to 5, 0 plus 6 is equal to 6. And each of these elements is the value of each of these elements is less than 7. That is, then we substitute these values here in this table, and now again add 1 to each of these elements. 1 multiplied by 0 is equal to 1, 1 multiplied by 1 is equal to 2, 1 multiplied by 2 is equal to 3, 1 multiplied by 3 is equal to 4, 1 multiplied by 4 is equal to 5, 5 is less than 7, 1 multiplied by 5 is equal to 6, 6 is also less than 7. Substitute these elements from 1 up to 6 are less than 7, therefore we substitute these elements in this table. And when we add 1 to 6, 1 plus 6 is equal to 7, so this element is equal to 7, therefore we divide this result. 1 plus 6, 1 plus 6 is equal to 7. We divide this 7, substitute this 7 here, and this 7 divided by this 7. 7 multiplied by 1 is equal to 7. the result is 0. So substitute this result in replace this element by 0. Substitute here this quantity 0, and again add 2 to each of these elements. 2 plus 0 is equal to 2. 2 plus 2 plus 1 is equal to 3. 2 plus 2 is equal to 4. 2 plus 3 is equal to 5. 2 plus 4 is equal to 6. Each of these elements up to this point is less than 7. Therefore substitute these result here, and when we add 2 plus 5 is equal to 2 plus 5 is equal to 7. Yes. Therefore divide this result. 2 plus 5 is equal to 7. This result is divided by 7. 7 multiplied by 1 is equal to 7 is equal to 0. Substitute this result, this remainder here, and when we add 2 to 6, 6 plus 2 is equal to 8. Divide this result by 7. 7 multiplied by 1 is equal to 7. This result substitute this remainder here, and so on. Therefore 3 multiplied by 0 is equal to 3. 3 is less than 7. Substitute this result in this table. 3 plus 1 is equal to 4. 3 plus 2 is equal to 5. 3 plus 3 is equal to 6. All these results are less than 7. Substitute these results in this table. 3 plus 4 is equal to 7. Divide the result 7 by the 7. The remainder is 0. Substitute here this 0, and 3 plus 5 is equal to 8. Divide this 8 is greater than 7. Divide this 8 by 7. 7 multiplied by 1 is equal to 7. The result is 1. Substitute this, replace this element by this remainder, and 3 plus 6 is equal to 3 plus 6 is equal to 9. 9 is greater than 7. Divide 9 by 7. 7 multiplied by 1 is equal to 7. The remainder is 2. Replace this element, this 9, by the remainder 2, and so on. Now the last column is 6 plus 0 is equal to 6. 6 is less than 7. Substitute 6 here. 6 plus 1 is equal to 7. Divide 7 by this 7. The remainder is 0. Replace this 7 by the remainder 0, and 6 plus 2 is equal to 6 plus 2 is equal to 8. Divide the result 8 by 7. The result is 1. Therefore replace this 8 by the remainder 1, and 6 plus 3 is equal to 9. Divide 9 by 7. The remainder is 2. Replace this 9. The result this 9 is replaced by the remainder 2. 6 plus 4 is equal to 10. 10 is greater than this 7. Divide 10 by divide 10 by 7. The remainder is 3. Replace this 10 by 3, and 6 plus 5 is equal to 11. Divide 11 by 7. The remainder is 4. Replace this element by 4, and 6 plus 6 is equal to 12. Divide 12 by 7. The remainder is 5. Replace this element by 5. Now each of these elements, when we operate every element of this set with itself and every other element of this set, the result, these are the result, these are the results, and every element in this result is again belong to the set Z7. Residue class is modulo 7 under the operation addition. Therefore addition is a binding operator on Z7.